We are on lesson 12 of unit 3, and today we're talking about sprite movement. The way that we make our sprites move is we use something called the counter pattern, and that counter pattern adjusts the X and Y position of our sprite periodically so that it appears that the sprite is moving. That counter pattern will live inside of our draw function so that it happens on a loop over and over and over again until we tell our program to stop. You should have worked through level 1 and also watched the video on level 2 in code.org. We're getting started with level 3. So what we want to do first is look at our code. So first, looks like we are initializing a variable, creating a sprite, and then assigning an animation to that sprite. We're going to have an animation of a jet and of a plane. And then we have this draw loop here. And the first thing is we set our background. And remember, we do that inside our draw loop so that every time the draw function is run, the background is recreated so as to give the illusion that these animations are moving. And then we have some comments in here to help us out. But the first thing is that the jet is moving up. So we're taking this animation and we're moving it up. And it looks like we're setting the Y position of the jet to be updated. So what's happening here is we're taking jet.y, which the initial Y value would be at 350 where it's first created. And then what we're doing is we're assigning a new value to this variable. And what we're deducting the value of that variable by 3 each time this program is run. But let's just take a look. If I hit run, I can see my jet is just moving upwards. That's again because the Y position of the jet is constantly being updated. Every time it's updated, its value is deducted by 3. And what we're asked to do is to make the plane move to the right. As you can see in this sample image, the jet is moving straight up and the plane is moving to the right. If I updated the Y position of my jet to move it up, think about what kind of position you'd need to change to move it to the right. And I know that the Y position determines where the sprite is on the vertical axis. The X position tells me where the sprite is on the horizontal. So I'm going to update the X position. The name of my variable, which is plane, that's my sprite. And then I'm going to do .x. And this is now going to update the X position of the plane. So plane.x equals, and I'm just going to try and do exactly what I see for the jet. So it'll be plane.x minus 3. And let's just give that a try. Aha, but since I'm subtracting 3, my x's would get smaller and smaller and smaller, and therefore would move off the screen to the left. So instead of minus 3, I'm going to do plus 3. And as you can see, my code works. It looks just like the image here. Let's move on. In level 4, we're asked if adding to a sprite's x coordinate makes it move to the right, how would you make it move to the left? So you might guess, and we kind of saw this in the last level, that subtracting a number would make the sprite move to the left. So what we're going to do here is we're going to update this code so that this little fly moves to the left across the screen. So let's run it first. As you can see, we just have this little fly being drawn. And happening here in the first 2 lines of code where we initialize the variable, create a sprite, and then set an animation to that sprite. Inside of our draw function, we're going to update the fly.x position. So we do fly.x equals, and then let's do fly.x. It's taking the previous value of that x position, and now it's going to assign it to fly.x minus 3. That's going to make the x position reduce by 3 each time the program is run. Let's give it a try. Aha, there we go. Level 5 asks us not to just move right or left or up or down, but actually move diagonally. So I want you to think about when something is moving diagonally, what it's actually doing is, in the case of this mouse over here on the right side of the screen, this mouse is moving down and right. So the way we're going to make the mouse move diagonally is to adjust both the X and the Y positions. So right now, if I hit run, my mouse is just moving down because in my code, the Y position is the only thing being updated. And there's a clever little tool we have in code.org. It's called this Watcher tool. And it's down here in the bottom right side of your screen. It shows us the values of our different variables. In our Watcher screen right here, we have mouse.x and mouse.y. So it's recording and giving you a numerical value of the X and Y position of our mouse sprite. Let's run the code again, and I want you to watch this part of the screen and look at your mouse.x and mouse.y values. So you can see the mouse.x is staying the same and mouse.y is increasing. And that's again because in our draw loop, we're updating the Y position to increase by 2 every time the program is run. So let's change the code so that our mouse doesn't just move down the screen, but also moves across. So let's make it move diagonally. I'm going to add mouse.x, and that will be assigned the value of mouse.x. And we want to move to the right, so we're going to add 2. So we're going to add 2. Let's try it. And there it goes. It's moving down and to the right. And then there's this challenge here where we want to set the sprite's rotation property so that it faces the direction that it's moving. So let's just do that too. And that's something that we don't want to happen every time. It's not like going to be updated every time the program is run. So that means that we're going to put this command outside of the draw loop. And I write mouse.rotation equals, and I want him to turn, I think, -45. I think that would get me there. Looks like it. There we go. Let's move on. I want you to complete level 6 on your own. So I'll meet you back here for level 7. In level 7, I want you to complete all 3 of these activities. I'll walk through them with you. In part A, we are going to apply the counter pattern to the rotation of the sprite. So instead of just moving the position around, we can actually change the rotation. So if we hit run in our program, we just have this static pan. Let's update the code so we use the counter pattern to update the rotation property of our sprite. So inside of our draw function, after the background, let's set pan.rotation equal to pan.rotation plus 5. Let's try that. And then hit reset and run. You can see my pans flipping around. It's kind of going a little fast. Let's change this to 2. There you go. It's a little slower. So the bigger number you use, the faster it's going to go. Smaller number, slower it'll go. Let's move on. B, let's run the program to see what's going on. Aha. So if you see that right at the beginning, you can see this motorcycle fly right off the screen. So what we want is our motorcycle to be moving diagonally. We want it to move up and to the right. And the way that we make our sprites move up is by subtracting from Y. And the way we make our sprites move to the right is adding to X. If we look inside our code, we can see that the X position is being added to, so that will make our sprite move to the right, which is good. But then for our Y position, it's also being added to, and that's going to make the sprite move down. So let's change this from a positive to a negative and try it out again. Hit run, and there we go. Our motorcycle's moving across the screen. In part C, we want to create this animation that has these gears moving together so that they appear to actually be working together. If we hit run, we just have these static gears. So let's give it a try. Let's just start making all these gears move. So inside my draw function, I'm going to put in a few new lines of code, and my different gears are labeled blue gear, green gear, and red gear. So let's start with blue gear, and we will set the rotation equal to blue gear dot rotation, let's say +5. And then we want to do the same thing for green gear and red gear. I'm a really big fan of just copying and pasting as much as I can to make this a little easier on myself. So I'm going to change this one to green gear, green, and then this one will be changed to red gear. And let's give this a try. Reset, run. Okay, so they're definitely moving, but they don't really look like they're moving together. And you might notice there's a little hint that we're given. They're not supposed to be rotating in the same direction. So if you take a look at the animation, you can see the blue gear is moving counterclockwise and the red and the green are moving clockwise. So let's change the direction of one or I guess two of the gears. We can either change the blue one or the green and the red one. Let's change the blue one. So let's change this positive to a negative, and then we reset and run, and it looks now like these gears are moving together. All right, the last two levels are for you to finish up on your own. Please reach out if you have any questions. Have a great day.